R is the rate as a decimal. Decimal? Yeah. Everything else is what it says, right? You have your growth or decay factor. It's either 1 plus R or 1 minus R, not either, not both. Okay, today, let's see. A 1 plus R is called exponential growth. It's a growth factor because the base is greater than 1. 1 minus R is called the decay factor because this is wrong. The base is between 0 and 1. We talked about that day 1. We are going to skip part C. It's fine. We'll do stuff like that later in the unit, not right now. Sorry about my editing. Okay, the value of a car in thousands of dollars can be approximated by that equation where T is the number of years since the car was new. All right, tell whether the model represents exponential growth or exponential decay. You have to look at the base. You are not dealing with the base of E, and so you have to look at the base and decide, is my base greater than 1 or less than 1? Less than 1. Okay, so since it's less than 1, it's decay. Exponential decay because 0.85 is less than 1. Yep. Okay, and now we're going to move on to identifying the annual percent increase or decrease in the value of the car. Lovely. Okay, I'm going to write down this formula at the top. So we've got y is equal to a, 1 minus the rate raised to t time. It's always time in years, by the way, unless it specifies otherwise. Okay, and here's what you have. You have 0.85. So we'll test your kind of quick maths here. So something was subtracted from 1 to get you 0.85. Did anybody know what it is? 0.15, yeah. So this will help you see it. How did you get that? Like maybe you, for some of us, this is easier than others, and that's fine. 1 minus, here's the rate, 0.15 raised to time. So that means that your rate is at 0.15. Again, how could you get that? By doing 1 minus what you see. If it's growth, you have to think about, okay, what was added? Okay, so this tells me that the rate is 0.15, but it's not really because you'd rather put it as a percentage. Okay, do you know how to move things back to a percentage? You can multiply by 100, which is the same thing as moving the decimal place to the right. So if you move your decimal place 2 to the right, then it would be a 15%. Are we increasing or decreasing? Decrease, because this is decay. So let's break this down. It says to write the exponential growth model. It does tell you that it's growth. So that tells you that obviously since it's increasing, that's why it's growth. So y is equal to a. Since it's growth, it's going to be 1 plus the rate raised to the time. That's a t. Sorry, it doesn't look like a very good t. There you go. And then we're just going to fill in what we know. Let's see. The a value is your starting amount. Do you see the starting amount anywhere? Where is it? 6.09 billion. This is a starting amount. A is what you start with. Let's see. Next up, we need the rate, which is right here. It's the percentage. I understand that this percentage has a decimal in it. That does not mean that that's what you use. You need to take the rate, the percentage, and move it 2 to the left. So that means that if I move this decimal place 2 to the left, whoop, whoop, and fill the empty spots with a 0, my rate is 0.0118. Okay, the only other thing you need is time. What's our time? Let's see. So years since 2000, and it's 2005. So it's been 5 years. 5 years. All right, we're going to fill in what we know. So y is equal to, we're not going to use like all the zeros. We're just going to use 6.09, by the way. Because it usually is going to say like in billions. So we're going to leave it in billions. 1 plus your rate is the 0.0118 raised to time, which is 5. Okay, and then you just get to go to your calculator and type it in. As long as you use parentheses, it's fine. Question about where's the x? How do I raise things to an exponent? This. Okay, this is the caret key, and it will raise things to an exponent for you. Or it'll give you something, a spot to raise it. Chemistry in a while. So we're going to do 4.546? Is it 457? 457. I'll write it down. So, let me see. I don't want to mess it up. 6 point. So we'll do that, 6.46. What are we talking about here, by the way? Units? Billions? Billions of what? People. Thank you. It's population, folks. Sorry. Okay, I'm not going to read this whole sentence or this whole paragraph. It says that, let's see, compound interest. Compound, because that's what we're doing. Compound interest is interest earned or owed on the initial balance and interest that was accrued in previous periods. It's done over specified intervals. So this is where you have to think about the number of times per year. You can see over here, here's what's new about it. It's basically the same as what we just saw, except that you have now an N that you have to deal with. And so that's where all of this stuff comes in. How many times per year is this section? Okay, how many months in a year? 12, good job. How many days? 365, we are not including leap year. Semi-annual means it happens twice a year. How many weeks in a year? 52. There are 4 quarters in a year, like there's 4 quarters in a dollar, and bi-monthly means every other month, so 6. Bravo. You deposit $9,000 in an account that pays 1.46 annual interest. Find the balance after 3 years when the interest is compounded. Because it says that word compounded, you have to use this formula. You can't use the one from the previous page. Obviously, it's exponential growth, but it's specific to like bank accounts. Okay, quarterly. What is my N? 4. All right, and then we'll get the rest of the stuff from up here. This $9,000 is my starting amount. So in this case, that is P. Each formula kind of does a little bit different. Typically, this is the one that Algebra 2 focuses on, not so much on the one on the previous page. Let's see, it pays, sorry, I switched colors on you, 1.46 percent annual interest. And so you need to move that 2 to the left, since I know it has a decimal, but that's not the decimal. That's the percentage. So what is it? R is 0.0146. Anything else? Balance after 3 years. This is T. T equals 3. Okay, and now you're just plugging it in, and so you have the formula right at the top of the page. The amount is equal to the principal. What's our principal? I already forgot. 9,000. Try and color code for your learning. And then we're going to do 1 plus, it's always plus because this is always growth because the money is always growing. The rate, which is that 0.0146 divided by the number of times per year, which is 4, raised to n times t. Okay, I'm going to put this in parentheses because if you don't put it in parentheses in your calculator, you're going to have a world pain. Please make sure that you do that. The number of times per year is 4. How many years? 3. Okay, so yes, you're just raising it to an exponent of 12. Right now, I need you to type it in your calculator. As long as you type it in exactly as you see here, you'll be fine. So please check that you have $9,402.21. If you don't, try it again. Let's go ahead and do the weekly. How many number of times per year would that be? 52. Okay, so I need you to write this formula out again, but you're going to use 52 for n. And then the next one is daily. So I'm going to scoot down. in a second. Okay, so I'm going to let you go ahead and work these out and let me know what the totals would be in those accounts. Did I get my interest rate right? Yeah. Actually type it in because you need to check your calculation abilities. Every calculator is different. I don't really know what yours is like, so I need you to test it out. Okay, the last thing we're asked on this page is how much interest did you earn in each situation? Okay, so you started with $9,000 and then you gained about $402 in each situation, right? How do you figure that out? If I have the total, I know I started with $9,000, how do you calculate the interest?
Subtract the total $9,000.
Yeah, just subtract what you started with. That's it. So it really is that easy. So you're going to, in this section, so subtract your starting amount. I'm just saying, generally speaking, so that this applies to any situation, not just this problem. Yeah, if I ask you how much interest, subtract the starting amount. So obviously we're subtracting 9,000 in each situation, and then you should have what is left over, which would be about $402 in each situation, but your cents are a little bit different each time. This would be 21, 90, 95. It's called, we usually say PERT is the math thing we usually say. Again, your P is your principal amount. We use E if it's compounded continuously because eventually things don't really get much different, even if you do it 1,000,000 times a year. Raised to the rate times the time. All right. You and your friend have accounts that earn annual interest compounded continuously. These are the key words, so it's not just saying like compounded monthly or anything. It says that word continuously. The balance A of your account is modeled by that equation. The graph shows your friend's account. Which account has a greater principal? And which account has a greater balance? All right, so here is your account. It's that equation at the top of the, or in the problem. So A is equal to 4,500. E raised to 0.04 T. Okay, it says what's the greater, well, we'll start with this. What is the greater principal? Who has the greater principal? Do you remember what principal is? The starting amount. What's our starting amount? 4,500. What is your friend's starting amount? Look at the graph. 4,000. Who has the greater principal?
We do.
We do. It says you, so I have the greater principal, which is the starting amount, which is $4,500 versus 4,000. Okay, and now who has the greater balance after 10 years? Where do you put 10 years? T for time, right? Okay, so you're going to go ahead and calculate yours. E raised to, and then you can put this in parentheses, 0.04 times 10. Let's talk about how you need to type it in. Again, parentheses are your friend. So your calculator should have an E button if you're dealing with a handheld calculator. It's typically above, you'll see the natural log, and then you'll see E to the X. And it should usually automatically prompt you to raise it to an exponent. So look for that button, and then you'll have to click Shift or Second. If you're on Desmos, you just have to type in an E and it knows what to do, which is nice. Okay, so evaluate that one, and then we'll talk about the graph. Okay, if you type in your calculator correctly, this is what you should get. Now the question is, how much does my friend have at 10 years? Okay, you go to 10, right, which would be here. I'll use like purple so you can see it better. We go up. There's a point can kind of follow it over. Who has more? They do. Look, this is the 7,000 mark right here, and it's obviously above that. So I don't know, it's like 7,300-ish. Does it really matter? No, not really. We're just asking who has more. Not me. Okay, they do. Your friend has more? More after 10 years. How do we know? Because this is what they have, and I only have 6,700-ish. Okay. And it's not just saying compounded, it's saying compounded continuously. If it says that, you have to use PERT. How much do you have after 5 years? Okay, so A is equal to, what is my principal amount? 4,250. There it is. E is part of the equation because eventually, if you compound it 5 million times a year, it doesn't make much difference. Okay, raised to the rate, which is, it says 5%. So you move that decimal 2 to the left, and it's 0.05. Yeah. So put this in parentheses, 0.05 times, what's my time? 5 years. There you go. Type it in one last time to make sure you know what's going on. We won't do the last problem. We're just going to end up with this one. So do this last one. The people are saying this. 5,457.11. You would look after the 0, since the number after the 0 is an 8. 5 or above, you give it a shove. And this is money, so put a $sign. Let's see.